Good day. We are now in week 2 of second quarter. This time, we will solve problems involving systems of linear inequalities in two variables. If two or more linear inequalities are solved simultaneously, this set of inequalities is called system of linear inequalities. To further understand, let's have the following examples. The first example, we have y is greater than 2x minus 1 and y is less than x plus 2. If we observe, we have two linear inequalities here. Now, we call these systems of linear inequalities because we have this symbol to denote that they are system. And this is a brace symbol. For the second example, we have negative 3x plus y is less than or equal to 6. And x minus 2y is greater than or equal to 4. Another example of system of linear inequalities because we have this symbol. And for the last example, we have 2x plus y is greater than 5 and 2x plus y is less than 4. So these are examples of systems of linear inequalities. Now, to solve problems involving systems of linear inequalities in two variables by graphing, we have the following steps. Number 1, draw the graph of each inequality on the same rectangular plane. But take note, we have to review on how to graph linear inequality. Second, shade the solution. And for the third, we have the solution set is the region where the shadings overlap. Let's have this example. Give the solution or solutions to the systems of inequalities in two variables by graphing. So we have this system of linear inequality. We have y is greater than 2x minus 1 and y is less than x plus 2. So for step number 1, draw the graph of each inequality on the same rectangular plane. But before that, let's solve first for the x and y intercepts of each inequality. Now, let's have y is greater than 2x minus 1. Take note, to find the x and y intercept, we need to change first the inequality symbol by equal sign. So we need to change the greater than symbol to equal sign. So we have y is equal to 2x minus 1. Next, we can now solve for x and y intercept. To solve for the x-intercept, we need to let y is equal to 0. So it means we will substitute 0 to y. So we have now 0 is equal to 2x minus 1. Now, we need to isolate the x variable on the left side of the equation. So, in layman's term, we need to transpose this. If we're going to transpose this will become negative 2x. Next, negative 1 will remain on the right side of the equation. So we have negative 1. To remove negative 2 beside variable x, we need to divide both sides of the equation by the number beside x, which is negative 2. So we divide both sides of the equation by negative 2. Now, negative 2 divided by negative 2 is positive 1. We have x. Automatic, we have 1 here. is equal to negative 1 divided by negative 2, we have positive 1 half. So, our x-intercept here, if we're going to write in terms of coordinate, we have 1 half for the value of x and 0 for the value of y. Next, we need to solve for the y-intercept of the first inequality. So we will let x is equal to 0. Now, we're going to substitute the variable x in this equation by 0. So we have y is equal to 2 times 0 minus 1. Next, simplify the right side of the equation. We have y is equal to 2 times 0 is 0 minus 1. Next, 0 minus 1 is negative 1. Therefore, our y-intercept in coordinate form, we have 0, negative 1. So we're done with the first linear inequality. Let's have the second. So the given second linear inequality is y is less than x plus 2. Next, we have to change the less than symbol into equal symbol. To solve for the x-intercept, just like what we did on the first linear inequality, we're going to let y as 0. And we're going to substitute y in this equation by 0. So we have 0 is equal to x plus 2. Next, we're going to isolate the variable x on the left side of the equation. So if we're going to transpose this, we have negative x. Take note that the symbol will be changed if we're going to transpose. So from positive, it will become negative. And if this is negative, this will become positive if we're going to transpose. Since this is positive, this will become negative. Now we will let positive 2 on the right side of the equation. No need for us to write this symbol because if we saw a number without a symbol, it is automatically positive. Now, we need to make variable x here positive. To make this positive, we're going to divide both sides of the equation by negative 1. Negative divided by negative 1 divided by negative 1 is positive 1. So we have x. 2 divided by negative 1 is negative 2. Take note, unlike sign, so we have negative here. Now our x-intercept is negative 2, 0. And for the y-intercept, we will let x as 0. So we're going to change variable x in this equation by 0. So we have y is equal to 0 plus 2. Y, simplify the right side of the equation, we have positive 2. Now our y-intercept is 0, 2. Okay, take note of the following points. We have 1 half 0, 0 and negative 1 for the first inequality, negative 2, 0 and 0, 2 for the second linear inequality. Now we're ready to graph the following linear inequalities in one rectangular plane since they are a system. So we need to draw first a rectangular plane. So let's say that this is our point of origin. And for the right side of the point of origin, we have the positive numbers 1, 2, 3. And for the left side, we have the negative numbers. We have negative 1, negative 2, and negative 3. Okay, and for the y-axis, we have 1, 2, and 3. And for the y-axis also, we have negative 2, negative 3. And don't forget to label this as x-axis and y-axis. Now, we're going to plot the following points. So for the first linear inequality, we're going to plot 1/2 0. So we can find 1/2 0 in this location. And don't forget to write also the coordinate, 1/2 0. And for 0, negative 1, we have this location, 0, negative 1. And for the second linear inequality, we have negative 2, negative 2, 0, and 2, 0. 0, negative 2 actually. This is 0, negative 2. So let me, okay, so we have changed already this one. Now, after plotting these points, we're going to decide if we're going to use solid line or broken line. Since the inequality used here is greater than and less than, we're going to use broken line. But if we're going to use greater than or equal, or it can be less than or equal, we're going to use solid line. Okay, so we're going to connect these 2 points by broken line, and another 2 points will be connected by broken line. So we have this. So we're done connecting the computed x and y intercepts. So for the first linear inequality, we use blue. And for the second linear inequality, we use red. Now, after connecting the plotted points, we have to decide where we're going to shade the graph. Okay, so for the first linear inequality, since we use greater than, we're going to shade this graph upward. And for the second linear inequality, since we have less than, we're going to shade this graph downwards. To visualize it clearly, let's have this software. So for the first step, we draw the graph of inequality, of the 2 inequalities in one rectangular plane. So the first thing we did was to plot the solved intercepts, and we connect these points by broken lines since we use less than and greater than. Okay, now we are in step number 2, which shade the solution. So since the first equation, inequality, we have y is greater than 2x minus 1. We use greater than, we're going to shade it upward. And for the second inequality, we use less than, which is y is less than x plus 2. We shade the graph downwards. Now, for the third step, the solution set is the region where the shadings overlap. Now, this part is where these 2 shades overlap. It means the solution set of the system is in this part. Now we will identify 5 solutions of the system. So let's have negative 2 and negative 1. Negative 2 and negative 1 is a solution of the linear system of linear inequality. Another, we have negative 1, 0, 0, 0, 1, 1, 2, and negative 2, 2. So take note, we can only find the solution set of the systems of linear inequality on the region where the two graphs overlap. Okay, now you can do your activity 1